This video is for those of you that are looking at percentages, looking at proportions, but you've actually taken two different samples to compare them to one another. So for an example, in the December 2018 issue of Consumer Reports, Consumers Union reported on their investigation of the presence of bacteria in packages of chicken sold in supermarkets. They then purchased both name brand, which the name brand was Perdue, and they also purchased store brand chicken in 25 U.S. cities. And laboratory tests found, I'm not even going to pretend to know how to pronounce that word, but some type of Campylobacter contamination in 33% of the 75 Perdue packages and 45% of the 75 store brand packages. So let me get my pen working here. Give me a second. Okay, so what happens is we are comparing two different things. We are comparing this Perdue name brand chicken versus just a generic store brand chicken, and we're trying to see if one may have more contamination than the other. Okay, so because we are looking at percentages and we came out with 33% of the Perdue packages having contamination and 45% of the store brand packages having contamination, we're looking to compare those to see, is this truly a big enough difference to say that the store brands had more contamination, or is this just random variability? They're really both the same. It's just kind of, we just happen to get it in this sample. So what we need to do is we need to run a test because we are looking at two completely separate samples and also looking at percentage results for each sample. We're going to be running what's called a two proportion z-test. Okay, so for my hypothesis, that hypothesis should reflect these two different proportions that I found in my problem. So for my null hypothesis, my parameter of interest is going to be the true proportion of contaminated chicken, and we're going to have to represent both of the proportions for each group. So what I'm going to assume from the very beginning is the proportion of contaminated chicken from the store, or from the name brand, just since that was listed first, we'll call that the proportion of P for Perdue, is the same as the proportion of S, which would be my store-bought chicken. Let me get my pen a little thinner here. Okay. Remember, this null hypothesis should always be equal to, and the two proportions that we are comparing should be the same. I'm going to assume that from the very beginning. But my alternative hypothesis should be whatever I'm trying to prove. Now, the proportion setup should be the same, but the question is asking, does it indicate that shoppers would be safer buying the name brand product? And if they're going to be safer buying the name brand product, as a tongue twister, sorry, then that would mean the name brand product would have less contamination and be a safer product to buy. So we're going to say that the Perdue, which is the name brand, has less contamination than the store-bought, and that is what I'm going to try to prove. So before I can run this test, I do need to check the conditions for proportions and make sure that they are met. So conditions for proportions, remember, are we have to have a random sample or randomized treatment in some way. This does not indicate to me that it's random. I'm going to assume that it is representative. I'm going to assume they did it randomly. Of course, you won't have to make any assumptions because you are doing your own study and you will make sure that yours is random. Number two, we need to check the success failure. to make sure that condition is met. So success failure is the number of successes has to be greater than or equal to 10, as well as the number of failures has to be greater than or equal to 10. And in this particular one, since we had two different samples we were looking at, they must meet for both samples. So if I'm looking at the Purdue sample, it doesn't tell me how many packages were contaminated. So I'm going to take my sample size, which was 75. I'm going to multiply it by the percent of packages that did have contamination, which was 33%. And when I type that in, 75 times 0.33 gives me basically 24.75, which works for that. And then if I do 75 times the number of failures, well, if 33% of the packages were contaminated, then 1 minus 0.33 is going to give me the percent of packages that were not contaminated. So when I subtract that out, 67% of the packages were not contaminated, and 75 times 0.67 is going to equal 50.25. Now, your calculator, if it asks you for these values, is not going to take a decimal. You can't have 0.75 of a chicken package. So you would want to say, I have 25 packages that were contaminated, and I had 50 packages that were not contaminated. If I look at the store-bought chicken using the same information, I had 75 in that sample as well, but for the store-bought chicken, we had 45% that were contaminated. 75 times 0.45 is equal to 33.75. You can also do it this way. So if I'm going to round that and say, okay, I had 34 packages, well, then I could go ahead and tell you the number of packages that were not contaminated without even having to do that math problem. Because if I had 75 in my sample and I know 34 of them were contaminated, if I take out those 34 from the sample size of 75, then 41 packages were not contaminated. So my success failure meets on all four of these parts. All of these are greater than or equal to 10. So that second condition is met. And then my third condition is we need to check that 10% condition for independence. And I don't need to as. Okay, so my sample size both were 75. If I multiply that by 10, I get 750. And I do believe that's less than the population of all chicken packages that I could look for. We definitely have more than 750 chicken packages that we could choose from. So I am convinced that I am okay to run this test. We said since we were looking at two different samples and the proportion in each sample, we were going to run a 2 proportion z-test. My calculator will do this test for me. If I go to Stat and over to Test, 2 proportion z-test is number 6. And the first thing it's going to ask me for is x1. This is the number of successes in the first sample. And I want to make sure that however I wrote my hypothesis is the first sample that I include here. So because the Purdue chicken was the first proportion listed, then I want the number contaminated, which is this 25 from our success failure. So we had 25 packages that were contaminated out of N, which is my sample size of 75. And then we're going to list the same information for the second sample that I took. So from the store-bought, I had 34 packages that were contaminated out of a sample size of 75. And I need to include also which alternative hypothesis I chose. And in this case, I chose the less than. So we're going to highlight the second option. And then we're going to calculate our test. So what I get is a p-value of, and not the p-hats, just the regular old p-value. If we round that, we get a p-value of 0.07. And I am typically going to use a 95% confidence interval to run these tests unless otherwise stated. So since my p-value of 0.07 is greater than the alpha level of 0.05, then I am going to fail to reject the null hypothesis. That means I do not have evidence of the alternative. So because my alternative was this right here, I do not have evidence that the proportion of contaminated chicken in the name brand is less than that of the store brand. Okay, and because I don't have this evidence, then I can't really say that would be safer in buying the name brand product. These proportions are really just a sampling variation. One's not really more contaminated than the other. Now, if we wanted to support that, we could also run the confidence interval. So if we went back to stat and went back to test, and instead of running the test, we came down and chose the 2 proportion Z interval, same type, just an interval instead of a test. That's letter B. All of the information is already in there from where we've already run the test. We want to make sure that that confidence level matches the alpha level we tested at. So a 95% confidence level matches up with the 0.05% alpha level because together they are 100%. And we can go ahead and calculate the confidence interval. And what my 2 proportion Z interval tells me is that from negative 0.2752 to 0.03516, this captures the true proportion difference between these 2 brands. And because 0 is in that confidence interval, that shows me that there is no difference between these 2 brands. You can use that for extra support. Okay, so you can follow this model just using your 2 samples to run the test.